So what is implicit differentiation? So what does implicit mean? So usually we're used to functions like y is equal to x squared or y is equal to sine x. And these are called explicit functions. And a simple way to think about it is by thinking that you can separate y on one side and everything with x on one side. But let's say you had something like x to the 4 plus xy plus y squared is equal to 0. How do you separate this equation? Like, or something more difficult than this. Let's say I gave you sine of xy plus xy squared is equal to 0. How would you separate these equations? It would take a lot of time and you'd have to be very careful with what you're doing. So these are called implicit equations because you can't really get x on one side and y on the other side. You can't get y in terms of x. Over here, y is in terms of just x. Here, y is in terms of just x. But here, x and y both combine to give you something else. It doesn't have to be equal to 0, by the way. It can be equal to something else. It can be x4 plus xy plus y squared equals 25, for example, right? And let's say you had a function like this, and let's say you plotted, right, different values of x and y. And now you want to find the derivative, of course. So how would you find the derivative of this? So let's think about it a little bit because this can be a bit tricky. So let y equal f of x, right? Let's just get that down there. So now a new equation is x to the power 4 plus x times f of x plus f of x all squared is equal to 25. Now what do? Now we try to take the derivative on each side. So we take the derivative, so d by dx of this side, and that should be equal to the derivative. Let me write that better. It's a bracket. And that should be the derivative of this side as well because we have to do the same operation on both sides. But the derivative of 25 is just 0, right? We know that. So we'll just leave that out for now. So the derivative of this thing right here, how would you do that? Well, x to the power 4 with respect to x. Well, we know how to do that. That's just 4 times x cubed. That's power rule. Plus, now you have two things. You have x and you have f of x. So you have to use the product rule. So this is a product of two functions. You have f of x as one function and you have x as the other function. So we take the derivative of x first, which is just 1, and you multiply it by the other thing, so f of x. So we just have f of x. Plus, now we leave x how it is, and we take the derivative of f of x. We don't know how to do that, so let's just leave it as f prime of x. That's the derivative of f of x. We're just calling it what it is. It's the derivative of f of x. Plus, how do you take the derivative of f of x squared? Well, you can use the chain rule. So you have 2 times the derivative of f of x times f of x to the power 1. And that is equal to the derivative of 25, which is 0. So that's done. Well, now you have 4x cubed plus, what's f of x? F of x is equal to y, right? So you have 4x cubed plus y plus x times, what's f prime of x? Well, if y is equal to f of x, then dy by dx is equal to f prime of x. Remember, this is just notation. This is all the exact same thing. So you have x times dy by dx. This is in brackets because you're multiplying these together. Plus 2 times, what's f prime of x? Again, that's just dy by dx. Times f of x to the power 1. This is to the power 1. F of x is just y. So you have 2 dy dx times y. And that is equal to 0. Well, what can we do now? To find dy by dx, we can just rearrange this equation. So if you bring dy by dx to the other side, or let's bring these to the other side. So you have minus 4x cubed minus y is equal to x dy by dx, or x times dy by dx, plus 2y times dy by dx. Well, now dy by dx is on the same side, you can just factorize it, right? So you're left with dy by dx times x plus 2y is equal to minus 4x cubed minus y. And now you can just divide both sides by x plus 2y, and you're left with dy by dx is equal to minus 4x cubed minus y divided by x plus 2y. And that is your dy by dx. Of course, it's in terms of x and y because our original function was in terms of x and y. So it's going to be pretty standard that you get the derivative in terms of x and y as well. But if you have to separate this equation or even a more difficult equation, well, some of them can't be separated. There is no way you can separate them. But let's say this could be separated, then it would take you a lot of chain rule and being very careful to get the same answer. And this is the correct answer. So let's do it. Let's do another example, but just do it much faster. So let's say we had sine of x times y. This is sine of x and y. It's two different functions. Plus yx squared plus xy squared is equal to 3. How do you find the derivative of this function? Well, you want to find dy by dx, so let's put that over here. Is equal to question mark. Well, we start with this. So this is a product of two functions. So you take the derivative of the first function multiplied by the second function. So you're left with y times cosine of x. Plus, you leave the first function how it is, sine of x, times the derivative of the second function, which is just dy by dx. Right? Plus, now it's again two functions. So what's the derivative of y? That's just dy by dx. So you have x squared dy by dx. Plus, you leave the first function how it is, that's y. And then the derivative with respect to x of x squared is just 2x. And then again, the product rule. So the derivative of x with respect to x is just 1. So you're left with y squared. Plus, x times the derivative with respect to x of y squared is going to be 2y dy by dx. And this is equal to 0, of course, because derivative with respect to x of 3 is just 0. Well, you can see you have dy by dx over here. You can just factorize it and rearrange the equation. So you're left with dy by dx. And then what do you have here? You have sine of x plus x squared plus 2xy. That's sine of x, x squared, and 2xy. And then on the other side, you have negative y cos x minus 2xy minus y squared. And then to find dy by dx, you can let's do it right here. You can just divide both sides by the coefficient of dy by dx, which is equal to minus y times cosine of x minus 2xy minus y squared, all divided by sine of x plus x squared plus 2xy. And that's how you take implicit derivatives. So the easy way to think about it is, imagine if y was just x, right? How would you take the derivative of that? So here you have y squared. Imagine if that was x squared. How would you take the derivative? That would just be 2x, right? So you take the derivative like that, but instead of 2x, you make it 2y. And since it's actually y and not x, you have that dy by dx just staying there, and you just add that at the end. And if it's just in terms of x, then you just take a normal derivative however it is. So derivative of x is just 1. So you just have 1 times y squared over there. So yeah, just think of y as x, take the derivative with respect to x of it, and then just add a dy by dx in front. That's like an easy way to remember it. But the intuition behind it is that you can use this thing right here, y is equal to f of x, and then you realize that actually, if you simplify further, then you do get the exact same thing. So let's do an example question and see what they ask us and see how we can apply this. So the equation of a curve is x cubed plus 3x squared y minus y cubed equals 3. Show that dy by dx is equal to that. Well, that's pretty simple. That's what we've been doing. So find dy by dx on this. So on the left hand side, with respect to x cubed just becomes 3x squared. Plus, well, these are two functions. This is 3x squared and y. So derivative of 3x squared is 6x. So that's 6x times y. Plus, derivative of y is just dy by dx. So you have 3x squared dy by dx. This is just the product rule. Minus the derivative with respect to x of y cubed is going to be 3y squared times dy by dx. Like as I said, imagine y was x. That would be x cubed. So you take the derivative of that, you would get 3x squared, and then you have a dy by dx in front, and then replace x with a y. So you're left with that. Is equal to the derivative with respect to x of 3, which is just 0. So we don't care about that. Well, now you can just rearrange this equation, right? So you're left with minus 3x squared minus 6xy is equal to, I brought this to the other side, is equal to dy by dx times 3x squared minus 3y squared. You can divide both sides by 3x squared minus 3y squared, so you're left with dy by dx is equal to minus 3x squared minus 6xy divided by 3x squared minus 3y squared. And now we need to factorize because it's not in the form that we wanted. So let's take minus 3 out on both sides. So you're left with dy by dx is equal to minus 3, and you have x squared plus 2xy. And then over here, if you take minus 3 out again, you have minus 3, and then you have y squared minus x squared. I just switched the order of these two around because I want the positive in front. Well, you can cancel out the minus 3's, and you're left with dy by dx is equal to x squared plus 2xy all divided by y squared minus x squared. And is that what we wanted to show in the first place? X squared plus 2xy divided by y squared minus. Yep, that is exactly what we need to show. So we have proven this to be true. So that's done. Let's do the next part. Find the coordinates of the points in the curve where the tangent is parallel to the x-axis. So what does that mean? So the tangent is, as I said, dy by dx gives you the gradient, right? And if it's parallel to the x-axis, what does that mean? That means, so let's say you had this right here. There's the x-axis, and this is the y-axis, as usual, right? If it's parallel to the x-axis, that means it looks like this. The tangent, let's say whatever the curve is, let's say it's like that. Parallel to the x-axis means it looks something like that. The tangent is just a horizontal line. Well, when will you get a horizontal line? When dy by dx is equal to 0, right? So if dy by dx is equal to 0, that's when the tangent is parallel to the x-axis. Because the gradient of this line is 0, so that means, or the slope gradient exact same thing. If it's equal to 0, that means the tangent is going to be parallel to the x-axis. Well, we already know what dy by dx is. It's x squared plus 2xy over y squared minus x squared. So we can write that again. So we have x squared plus 2xy all divided by y squared minus x squared. And that's equal to 0 because this is dy by dx and that's dy by dx and it's equal to 0. Well, multiply both sides by y squared minus x squared, but that doesn't really do anything because it will cancel out. So all you're left with is x squared plus 2xy is equal to 0. What can you do now? Well, you can factorize an x. So you have x plus 2y is equal to 0. So you have either x is equal to 0 or x is equal to negative 2y. That's just solving from this equation right here. Well, we have to find the coordinates of the points in the curve where it's parallel to the x-axis. So when x is equal to 0, what is y equal to? Well, we have 0 cubed plus 3 times 0y minus y cubed equals 3. So you have 0, 0, and minus y cubed equals 3. So minus y cubed equals 3. So y cubed is equal to minus 3. And then y is equal to the cube root of minus 3. So we can write that back here. So one of the coordinates is 0 and cube root of minus 3. And the other coordinate is minus 2y. And then, well, let's solve this equation. So x is equal to minus 2y. Well, if you put minus 2y in for x here, you'd get minus 2y cubed is minus 8y cubed plus 3 times minus 2y squared is 3 times 4y squared times y minus y cubed is equal to 3. Well, now this equation is just in terms of y cubed, so we can solve that. So we have minus 8y cubed plus 12y cubed minus y cubed equals 3. Minus 8 plus 12 is positive 4. Minus 1 is positive 3. You can divide by 3 on both sides. So you're left with y cubed is equal to 1. Y is equal to the cube root of 1, which is just equal to positive 1. It has other answers too, but those are complex. We don't worry about them. So we can just write positive 1 as our other solution. And that's it. Those are the 2 points on the curve where the tangent is parallel to the x-axis. So at 0 and the cube root of negative 3, which will be somewhere over here. So there will be a tangent here parallel to the x-axis. And wherever the point 1 is on the y-axis, so wherever, let's say that's 1. And then wherever x is equal to negative 2y. So that's actually equal to negative 2. So negative 2, 1 is the other point. Because we have to have it as numbers. Since x is equal to negative 2y and y is equal to 1, then x is equal to negative 2 times 1. So negative 2 and 1. So here and here is another point where the tangent will be parallel to the x-axis. Let me draw it parallel. So yeah, that's all about implicit differentiation. I hope that makes sense. And yeah, like, comment, share, subscribe, all of that, and let me know what you want to see in future videos.